Okay, so we're talking about the polar coordinate system. This is a different system than the rectangular coordinate system. The rectangular coordinate system, we identify a point by an x-coordinate and a y-coordinate. And so we move along horizontally on the x-axis, then we move along on the y-axis, and it makes this rectangular grid system. We're allowed to graph points very easily that way. However, sometimes it's easier to graph things using the polar coordinate system. Just a different system to be able to graph points. Note that the polar coordinate system uses distances and directions to specify a location. So two things, distances, direction, okay? So we'll start off with what we call a polar axis. So a polar axis is actually a ray, okay? Just a ray, starting at some origin, just a horizontal ray. And then what we do is we define an angle theta by counterclockwise rotation and r, some measure of length r. So I could define a location, say this spot, simply by measuring this angle theta and knowing what that distance r is. So again, if we have an x, y axis, and I was graphing a point here by 2 units here and 3 units here, I could do that same thing by if I just had a ray here and I talk about an angle with respect to that ray and a distance r. Okay, so that's all we're really doing, is we are, instead of graphing points using x's and y's, we're talking about in terms of r's and theta. So this is a point P then determined by two things. Instead of x and y, it's r and theta. Okay, so theta is defined to be a counterclockwise rotation. Counterclockwise is this way. Now, if theta was a clockwise rotation, okay, it'd be a negative number, and we'd go this way, right? And if r was negative, suppose we wanted to graph, an r value that's less than 0, then we'd have our ray here, and suppose we had some point r theta, but r is negative. Well, we'd graph it like if it was positive, so we'd move our angle theta, get our value of r here, but then we take the absolute value of it, that was the absolute value, and then go this way. Think of it like a dotted line. So this would be this point right here, P of r theta. If r is less than 0, it's negative. Okay, we just flip it around. Okay, let's take a look at some examples now. So we have 3 examples. I just want to graph these points. Just like if I wanted to ask you to graph the point on a rectangular coordinate system of 4, 5, we'd be 4 on the x-axis, 5 on the y-axis. Now I'm asking you to graph these points, r theta. So we start off with our polar axis here. Okay, it's a ray. You can get it that way. We move 3 pi over 4 according to this. So 3 pi over 4 put us right about here. And then when I make this line segment, all I want to do is make a line segment of length 1. Okay, so this is 3 pi over 4, the distance, and this is length 1. And that gives me the point 1, 3 pi over 4. Okay, so there's how we graph that guy. Now if we want to graph point 3, negative pi over 2, start off with our polar axis. Okay, first go negative pi over 2, negative pi over 2. Since it's a negative, we go clockwise, and then we get 3 as a distance, so 3 is much larger than 1. So we'll have it right down there. Okay, so that's 3 negative pi over 2. Okay, and then finally, if I wanted to go negative 4 pi over 4, I want to go negative 4 pi over 4, start off with my polar axis. Where's pi over 4? Pi over 4 is right here, right? So instead of going 4 this way, right, that's distance 4. I want negative 4. So negative 4 will put me right here. So this is the point, negative 4, pi over 2. Again, I went pi over 2, and then I said negative. Okay, so that distance is not positive r, it's negative r, so I'll go down here. Okay? Okay, suppose we have a point P of r theta, the same as P of xy. In other words, if this distance here is x, and this distance is y, and I create a little triangle here, where the hypotenuse is length r, and this is an angle theta. So the same point as determined by x, y is the same point as determined by r, distance, and then theta. Okay? Suppose we have this. Then you can see that, and as we already know, cosine of theta, right, is adjacent over hypotenuse, x over r. So if I solve for x here, okay, if I solve for x here, then I'd get x equals r cosine theta. So x equals r cosine theta, right? Cosine theta equals x over r, right? Good. That means if I have an r and a theta, I can convert it to an x value in terms of rectangular coordinates, right? Same thing with y. So what's y? Well, we know that sine of theta is opposite over hypotenuse, y over r, so I multiply both sides by y. Okay, then I'll have y equals r sine theta. Okay. All right, so that's converting from polar to rectangular. Well, how do I go from rectangular to polar? Well, you have to know a couple things. Number one, you have to know Pythagorean theorem, x squared plus y squared plus r squared. You give me an x and a y, and I can find out what r is, right? The other one is we know that tangent of theta, right, is opposite over adjacent, so opposite over adjacent. So we can figure out what theta is given the ratio of y to x, okay? And then once we have tan theta equals this ratio, we do inverse tan, and there you go, okay? So again, x can't be equal to 0 here. Alright, so this is how we convert from polar to rectangular and from rectangular to polar. And let's look at some examples. Okay, so let's find the rectangular coordinates for the point that has polar coordinates 4, 2 pi over 3. So we're given polar coordinates, we want to find rectangular coordinates. What do? We use our simple formula, x equals r cosine theta, y equals r sine theta. So x equals r cosine theta. What's r? R is 4 times cosine 2 pi over 3, which equals 4. Now cosine of 2 pi over 3 is equal to negative 1/2. So my x value turns out to be negative 2. Okay. Now let's do y equals r sine theta. So it'll be 4 times sine of 2 pi over 3, which equals 4 times root 3 over 2. 2 goes into 4 2 times, so I get 2 square root of 3. Okay? So this is its polar coordinates, therefore its rectangular coordinates are the point negative 2, comma 2 square root of 3. Okay? Okay, now let's find the polar coordinates for the point that has the rectangular coordinates 2, negative 2. Let's first find the value of r. We know that r squared equals x squared plus y squared. So I'll have 2 squared plus negative 2 squared equals r squared. So 4 plus 4 equals r squared. R squared equals take the square root of both sides, so I get plus or minus 2 square root of 2. There are two values, okay? Fine. Let's do tan of theta. There's 2 now. Tan of theta equals y over x, so I'll have negative 2 over 2, or tan of theta equals negative 1. When does tangent of theta equal negative 1? Well, tangent of theta equals negative 1 at 3 pi over 4, negative pi over 4. Okay. 3 pi over 4, or negative pi over 4. How do we put all this information together? Well, what quadrant is 2, negative 2 in? 2, negative 2. As on the rectangular coordinate system, 2, negative 2, in quadrant 4. So therefore, if I have negative pi over 4, which is in quadrant 4, okay, then I'm probably going to want positive 2 root 2. Why? Because if I start with my polar axis, I move pi over 4 this way, I want to be in that quadrant, then I'm going to take positive distance of 2 root 2. But if I do 3 pi over 4, I'm in quadrant 2, but I need to be in quadrant 4, so I'm going to take that r value, negative 2 root 2, with that 3 pi over 4 to get it. Negative 2 root 2, 3 pi over 4. Okay. Now we're given an equation. What we want to do is change this equation that's in rectangular coordinates into polar coordinates. Simply use the things that we know. X equals r cosine theta, y equals r sine theta. So I'll have here x is r cosine theta, y r sine theta, have r squared cosine squared theta equals 4 r sine theta. R is not a variable, r is a value, a number divided by r. So I get r cosine squared theta equals 4 sine theta, divide both sides by cosine squared. R equals 4 sine theta over cosine squared theta. This isn't wrong, but it's easier to simplify. Sine theta over cosine theta is equal to tangent theta, and 1 over cosine theta equals secant theta. So this will be 4 tan theta secant theta. So r equals 4 tangent theta secant theta. That's an equation in polar coordinates. We started off with the equation in rectangular coordinates, converted to polar. So the last one, I convert the equation from polar to rectangular. We've got r's and thetas, we want x's and y's. One thing that you can do is, we have an equation that says x squared plus y squared equals r squared. We don't have r squared here. Can we get r squared? Yes, just multiply everybody by r. Who parties? Everybody. So I'll have r squared equals 2r plus 2r cosine theta. R squared, of course, is x squared plus y squared. Okay. We know r cosine theta is equal to x. This is equal to 2r plus 2 again. That's x, right guys? Yes. You can subtract the 2x, x squared plus y squared minus 2x equals 2r. Again, we don't want r. We'd rather have r squared. So if I square both sides, then I'll have x squared plus y squared minus 2x squared equals 4 r squared, but r squared is x squared plus y squared. So I'll have x squared plus y squared minus 2x squared equals 4 times x squared plus y squared. Now, this is an equation. It's not pretty. This is much easier to write than this one, but yet they mean the same thing. This is an equation just in x's and y's. This is an equation in r and thetas. Okay, you'll see that some equations are very easy to graph using polar coordinates and tough using rectangular, and vice versa. Sometimes they're easy in rectangular coordinates and much more difficult to write in polar coordinates.